In this video, I will look at using the quadratic formula to solve quadratic equations. So this will be the third way we have seen for finding the roots of a quadratic equation. And the quadratic formula is given here, and I will put a nice red box around this. So using the general formula of a quadratic equation, or the general form, ax squared plus bx plus c equals 0. That's key. We can find the roots by using the formula x equals, and now notice a few things important about it, negative b plus or minus, that gives us both roots. And underneath the square root sign, b squared minus 4ac, the whole thing over 2 times a. So really, it's important we put our equations into the general form, and then we just have to identify what a is, what b is, and what c is, and substitute those into the formula. So let's take a look at an example. All right, so here's my example. We are asked to solve using the quadratic formula. And we notice that our equation, our quadratic equation, is already in general form. We have the x term, the x squared term, the x term, and the constant equals 0. So before we begin, if you want, maybe it's helpful for us to establish what a, b, and c are. So a is equal to the coefficient of x squared, which is 1. b is equal to the coefficient of x, which is -2. Don't miss that negative. And c is the constant, which is -48. So let's take a look at solving using the quadratic formula, and I have repeated it right over here. So we'll say that x is equal to, now we have to plug in negative b. So I'm going to write the negative, and b is -2, and it's plus or minus the square root of b squared, which is -2 squared minus 4 times a times c. And the whole thing is over 2a, which is 2 times 1. All right. So all of the values are substituted in there. You don't have to write that if you want to skip some of those steps in your head, but as you're learning, I do suggest that you write everything out. So x is equal to this -1 times -2, which will be 2, plus or minus -2 squared is 4, and now we have to multiply -4 times 1 times -48, which is positive 192. Okay, so we have a -4, it's multiplied by -48, and positive 1, which is positive 192. Put that all over 2. Another line down. All right, so x is equal to 2 plus or minus the square root of 192 plus 4 is 196. We'll put that over 2. Next, we need to find the square root of 196, if that is a perfect square or if it might be a mixed. Let's take a look at that. So 196 on my calculator, square root that, it is 14. So let's see, we'll put that one more line down. So it is x equals 2 plus or minus 14 all over 2. Now the next thing we have to do is the numerator, right? So that's where we have the plus or minus. So this is where it breaks into the two roots. We'll get x equals 2 plus 14 over 2, and x equals 2 minus 14 over 2. So we have to continue them with each of those. This becomes 16 over 2, x equals 8, and this becomes to subtract 14, which is negative 12 over 2x is equal to negative 6. So we do have our two roots, x equals 8 and x equals negative 6. This is an example where the square root in here produced an integer root, didn't it? We have 14. Now that won't always happen. Sometimes we will have irrational roots, which means it's best to leave them under the square root sign. In this case, we will look at an example where we will get irrational roots. We don't need to worry about dividing through by 2 in this case, like we did with completing the square, because we are going to use the quadratic formula. And let's just write that over here again, minus b, x equals minus b plus or minus square root b squared minus 4ac all over 2a, all right? It's already in general form, so let's write out our values for x. B is negative 7, so the negative of negative 7 plus or minus the square root of negative 7 squared minus 4 times 2 times negative 5. All that's under the square root sign. Let's put that all over 2 times a, which is 2 times 2. So I'm writing this line so everybody can see the a, the b, and the c subbed in. Let's simplify. 7 plus or minus the square root of negative 7 squared is 49. And I've got negative 4 times positive 2 times negative 5. So it'll be a positive. We have negative times negative, so it's positive. And 4 times 2 times 5 is 40. Let's put this over 4. All right, continue. We need to finish underneath the square root sign. X equals 7 plus or minus the square root of 89 all over 4. So the square root of 89 does not simplify any further. It is not a mixed radical. It is left as a square root of 89. And we have our roots. X equals 7 plus the square root of 89 all over 4. And x equals 7 minus the square root of 89 all over 4. And those are our irrational roots. So in that last example, even though we had irrational roots, those values are still part of the real number system. What about getting roots that are not real roots, no real roots? So let's take a look at how that looks when we are using the quadratic formula. And again, I'm just going to write it out here, minus b plus or minus square root b squared minus 4ac all over 2a. Okay. I'm following that so that I can sub my values in for x here. The negative of b, now b is negative 8. So negative 8 is, I'm going to start that with an 8. Plus or minus, okay? 8 squared, 64, minus 4 times 2 times 24. We'll break that one down for now. We'll get back to it. And put it all over 2 times 2. Okay, x equals 8 plus or minus the square root of 64, and grab my calculator, 4 times 2 times 24, 192. Oh, but it's minus 192. Okay, it's a negative because we have negative here And there are no other negatives to turn that into a positive. And it's over 4. Now, continuing, the same thing we have to do inside the radical sign next, right? Order of operations. So x equals 8 plus or minus the square root of 64 minus 192 is negative 128. And that goes over 4. Now, if you try to put that in your calculator and do a square root, that isn't going to work, right? We don't have any values within the real number system that when they are multiplied by each other, we get a negative. So these are not real numbers. However, they are complex numbers, okay? Complex numbers takes into account the square root of negative 1, which we will see in a future lesson, but for now, we'll just say no real roots. Okay, I can't go any further. Well, I can split them up, I suppose. X plus the square root of negative 128 over 4 and x minus the square root of negative 128 over 4. But those are not real numbers. So we're going to stop there at that. And that's how you use a quadratic formula.